All right, so we're going to look at ratios and rates. We're, we want to first think about kind of language wise. If we notice that these both have the same root word, right? Ratios and rates. And that's the same as rational numbers. And so if we look at our ratios and rates, what we're going to see is that we can talk about a ratio as being a quotient of two numbers, of two quantities. So we tend to say things like 1 to 2. That's also written as 1 to 2 or 1 to 2 like this. Kind of a historical note, in some European countries, especially mainland Europe, they write this as their division sign. And if you take that symbol and the fraction bar and put them together, you get what we tend to use as the division bar here. And that's because they have the same meaning. Now, to the numbers, it doesn't matter if we're talking about a ratio, a fraction, or a division. It's all the same pattern. A lot of how we get to this is our language choice. The task we're doing does a certain thing that to the numbers acts like division or acts like a fraction. So let's look at how we would write these. 15 to 23. Well, the first thing becomes the numerator, and the second thing becomes the denominator. And this order is important in doing ratios. So let's look at another one. I can take $25 to $15. This would happen something like we make $25 profit, but to the $15 cost. And so our ratio is $25 over 15. And the thing we're going to find is this unit can be treated like a variable, and so they'll cancel each other, or they'll turn into a 1. And then notice that 25 is 5 times 5, and 15 is 3 times 5. So those also turn into 1. And we get that the ratio of $25 to $15 is 5 to 3. Well, ratios can also come with other quantities. I could have some decimal value I measured, 2.6 to 3.1. I still write the first thing as the numerator and the second thing as the denominator. But if we think back to our unit on decimals, well, I could multiply this until I get rid of the decimals. And so what I want to do is I want to multiply by 10. And so that gives me 26 over 31. And this is a better way of talking about our ratios, is to remove the decimals and talk about it as a pure fraction. All right, let's look at another example. And we're going to start with improper fractions, or not proper fractions of mixed numbers. Well, this is going to turn into a ratio. We probably want this to be a pure fraction. So we're going to convert this to an improper fraction. 5 times 1 plus 1 is 6 over my original denominator. 10 times 2 is 20, plus 7 is 27 over the original denominator. And now I can write this as an improper fraction. noting that an improper fraction is the same as division, and so this becomes multiplication by the reciprocal. Right? A division is multiplication by the reciprocal. And if I look at these multiplications, 6 is 2 times 3, 10 is 2 times 5, and 27 is 3 times 9. So this 3 and this 3 will make each go away, and this 5 and this 5 will go away. And so I have 2 times 2, or 4 to 9. Now, one of the historical places that ratios came up was early geometry. And so what we're going to do is look at some ratios that can be found in geometrical objects. And so if I have a rectangle that has a length of 7 feet and a width of 5 feet, I could ask myself, what's the ratio of the width to length? And so the width is 5 feet, so this would be 5 feet to 7 feet, which is 5 feet, right? The first thing on the numerator, the second thing in the denominator. The repeated units cancel, and their ratio is 5 to 7. I could ask, what's the ratio of the length to the perimeter? And we have to remember that the perimeter of a rectangle is twice the length plus twice the width, because I'm adding up how long it takes me to go to each side, and I have 2 sides of 7 and 2 sides of 5. So this is equal to 2 times 7 plus 2 times 5, or 14 plus 10, or 24 feet. And so the length to the perimeter is 7 feet to 24 feet, or 7 feet over 24 feet, or 7 to 24. There is a special type of ratio called rates. When we have a measured quantity that is different from each other, so rates compare different kinds of quantities, or different types. So a common one is 3 miles in 33 minutes. Well, I'll write this as a rate by taking 3 miles to 33 minutes. Noticing that both are divisible by 3, that's 1/11 miles per minute. And so rates are very useful because they relate two different quantities. And miles per hour is a common way that we talk about a rate of travel. Let's look at some more rates here. So if I have a board that I have to put 10 nails for every 6 feet, well, that has 10 nails. I keep my unit upstairs per 6 feet, which becomes, well, both these are divisible by 2. So that's 5/3 nails per feet. Let's continue looking at some rates here. Let's say I have a cost. Oops, let me change colors here. I have a cost of $2,160 for every 12 weeks. So I can write this as $2,160 per 12 weeks. Now, I notice both are divisible by 2. Let's see, that's 3, 9. Both are divisible by 3 because these add up to 9. So I'm going to divide by 3. So 12 divided by 3 is 4. And 2160 divided by 3. Let me write that out. 720. And I notice really quickly that both are divisible by 2. Let's see if this is divisible by 4. Let's see, 4 goes into that. So I want to check to see if 720 is divisible by 4. Factoring's fun, isn't it? Once. Yes, it is. 8. And zeros left over, so this gives me $180 per 1 week. And this is actually a nice thing to have. It's telling me how much I need to budget to cover that cost. I need to make sure I have $180 per week. Well, there's a special type of rate called a unit rate. And a unit rate makes the denominator one. So let's say I get 360 miles on a 16-gallon gas tank. So I write this as a rate of 16 miles per 16 gallons. But because I want the denominator to be 1, I'm going to do the full division, long division. I'm not going to try to simplify it. And so 16 goes into 36 twice. 2 times 16 is 32. Subtract, I get 40. And let's see. 16 goes into 40 twice also. And I get 80, so I have to put a decimal point here. And, right, I need to pull down because I'm going to continue my decimal point over. I'm going to decimalize this because that way I will have no fractional part. And 16 goes into 85 times. And so this is 22.5 miles per gallon. And that's my unit rate. It tells me how many of the top things I get per one of the bottom thing. All right, let me clean my blackboard here. We can look at unit rates. For money specifically, if there's a unit rate on an item, we'll call it the unit price if it's in money. And the unit price is the price of the item divided by the number of units. So let's look at some unit prices. In fact, let's compare two ways of selling something. So I can buy 4 bars of soap in a package for 99 cents. Or I can buy 5 bars of soap in a package for $1.19. So if I want to compare these two things, what I want to compare is the unit price, the cost per 1 bar of soap. So I take my price, 0.99, and I divide it by 4 bars. So I'll do this as division. Keep my decimal point up above. So I'll do my long division here. Whoops. Did I? Let me double check everything I have here. Feel like. Let me go back here. So 0.99 divided by 4. 4 goes into this twice. 2 times 4 is 8. 1. Bring down the 9. 4 goes into that 4 times. 4 times 4 is 16. 3, bring down an additional 0. 4 goes into that 7 times, which is 28. Let me scroll up just a little bit. And so I bring down another 0. And so we have the unit price, if I buy it this way, is $0.2475 per bar, or roughly 25 cents a bar. We'll do it in cents. 25 cents per bar. If we want to compare, we'll round it to the nearest penny. If I do my unit price over here, and again, I'll do this as a division. So 5 goes into 11 twice. 5 goes into 19 3 times. And goes into 48 times. And so the unit price here is $0.238 per bar, or about 24 cents per bar. And so I save about a penny per bar if I buy the 5-pack. And so this is our introduction to rates and unit rates. We'll hopefully be using this to, add to our mathematical knowledge.